This video will show you how to diagnose deficiencies and revive dead soil without buying expensive fertilizer. Synthetic NPK fertilizers, like those from the NPK myth, spoon-feed only 3 macronutrients, ignoring the 39 other essential minerals. In the living system, plants secrete sugars and proteins, called exudates, to attract microbes. These microbes solubilize nutrients and deliver exactly what the plant needs, directly to the root wall. The law of the minimum dictates plant survival. Plant growth is not limited by the total abundance of nutrients, but by the scarcest one. If a plant lacks magnesium, pumping it full of nitrogen will not force it to grow. You must diagnose and fix the specific missing stave. Fermented rice water is an excellent catalyst to wake up the soil. First, wash and collect the cloudy water. Second, ferment it for 3 to 5 days until it has a faintly sour smell. Finally, dilute 1 part fermented water to 10 parts fresh water and apply directly to the root zone. For an immediate rescue of potassium and immunity on demand, use onion skins. The skins are rich in potassium, calcium, magnesium, and iron. Steep the dry skins in a quart of cool water for 24 to 48 hours until the liquid turns deep amber. The secret weapon is quercetin, which acts as a protective shield against fungal infections. A nitrogen blast can be created using green kitchen scraps. Submerging them for 2 weeks causes bacteria to burst plant cells, releasing locked nitrogen. The average kitchen produces more nitrogen in a week than a small garden needs in a month. Remember, this liquid is incredibly potent and must be diluted 1/30 before applying only to the root zone. The Alchemist Brew is a full-spectrum nutrient rescue. It combines banana peels for potassium, crushed eggshells for calcium, Epsom salt for magnesium, and used coffee grounds for slow-release nitrogen. Blackstrap molasses is the secret engine, feeding microbes and accelerating the brewing process from weeks to just 3 days. Liquid rescues fail without structural integrity. Compacted dirt leads to water pooling and suffocating roots, promoting toxic anaerobic bacteria. Aggregated soil, however, allows water to sink deeply and creates air passageways. Structure is the permanent cure for hard summer concrete and sticky winter mud. Hügelkultur, or hill culture, creates a permanent underground sponge. It involves burying thick, decomposing logs and branches, topped with leaves, grass clippings and compost, and then 12 inches of rich topsoil. This acts as a subterranean reservoir, eliminating the need for daily watering and synthetic feeding. The biological timeline of buried wood has 3 stages. Year 1 is the sponge, where wood absorbs and releases moisture during drought. Years 2 to 10 is the slow feed, where fungi digest the wood, slowly releasing nutrients. A first-year warning reminds us to always top dress with compost if burying fresh wood to avoid nitrogen consumption by microbes. Biological tillers drill deeper than any plow. Daikon radish breaks solid clay and leaves water channels. Comfrey mines hidden potassium, bringing it to the surface leaves. Alfalfa finds deep aquifers and pulls up unreachable trace minerals, breaking hardpan. Nitrogen fixers pull fertilizer out of thin air. Plants like lupines and clover form symbiotic relationships with bacteria, converting inert nitrogen gas into plant-available fertilizer in the root nodules. The golden rule of green manure is to cut these plants down before they produce flowers or bean pods, ensuring the nitrogen remains in the soil. The golden rule is that nature never leaves soil bare. Protecting the surface with organic matter is 20% of the effort that solves 80% of soil problems. Actionable surface mandates include never removing mulch, using the 1-inch maintenance rule of compost, and utilizing the chop and drop method to let earthworms till debris underground. By fixing the foundational biology, you break the cycle of the fertilizer industry. The closed-loop garden uses kitchen scraps, cover crops, and microbial ferments to create a thriving, disease-resistant soil biology, leading to nutrient-dense, high-yield harvests without spending money.